So, hello people, welcome to the channel. And we are going to start free GATE computer science preparation, okay, for GATE CSE aspirants. And this first series is going to be for engineering mathematics subject. This subject, engineering mathematics, is for every branch, not just computer science. So, if you are from other branch also, you can have a look at this. But the examples that we will be using here, that'll be from computer science perspective. So, yeah, that's it. Let's go ahead and let's see what happens in the engineering mathematics. But first, let me tell you something. We studied sine theta, cos theta, okay, entire trigonometry for 3 years in school, but we never used it once in real life. Tell me, have you ever used it once in real life? And now here's the engineering mathematics, and where we will study the things like linear algebra, calculus, probability, statistics. This is all we are going to learn in the engineering mathematics. Okay. So here's engineering mathematics, and somebody expects you to master it for GATE exam. What's the point? So just give me 10 minutes and I'll show you that every app on your phone, every recommendation, every filter, every search result is running on exactly this mathematics. And the engineers who built those applications, they use it every single day. Okay? So engineering mathematics is important. But let's see why engineering mathematics is important. Okay, so we have linear algebra, we have calculus, we have probability, statistics. This is all we are going to learn. So these three pillars are there in the engineering mathematics. Okay, we'll talk about them one by one. But first of all, why should we learn or study engineering mathematics? So first, why linear algebra? This is going to be the first topic that we'll be learning in engineering mathematics series. So why do we study linear algebra? Let's talk about this. All right, so let's look at why in linear algebra. Why do we study linear algebra? Okay, so as you can see, every image that you can see on a screen or on a computer is a matrix. This 1080p photo is literally a 1920 by 1080 pixels matrix. Okay, and matrix is a group of numbers. This is how the matrix looks like. This is a 2 by 2 matrix. So this is a 2 by 2 matrix, and this is how the matrix looks like. In the linear algebra, we'll be learning matrix and determinants and all that. So computer screens use the matrices all over. Okay, when Netflix recommends you a movie, it is using a technique called matrix factorization. What is it? Matrix factorization. इट डिकम्पोजेज अ जायंट मैट्रिक्स, बहुत बड़ी मैट्रिक्स होती है यूज़र रेटिंग्स की. ओके, जो यूज़र्स होते हैं वो रेट करते हैं ना मूवीज़ को, तो यूज़र रेटिंग्स की बहुत बड़ी मैट्रिक्स होती है. उसको नेटफ्लिक्स का रिकमेंडेशन इंजन जो है उसे फैक्टराइज करता है, डिकम्पोज करता है टू फाइंड पैटर्न्स. एंड दिस इज हाउ द नेटफ्लिक्स रिकमेंडेशन इंजन recommends you new movies. See, because you have added this particular movie to your list, these are the recommended movies. Okay, because you have watched this particular movie, these are the recommended movies for you. So Netflix recommendation engine के अंदर linear algebra काम कर रहा है. Okay, almost everywhere linear algebra is working, in computer, in 3D graphics. Okay, in computer graphics, everywhere the linear algebra is working. Okay, when you open Spotify, okay, on your phone, and it says daily mix, or because you listen to Arijit Singh, Spotify is looking at basically millions of users, millions of songs, and figuring out patterns. अगर आपने अरिजीत सिंह के गाने सुने हैं तो आपके डेली मिक्स के अंदर अरिजीत सिंह के गाने होंगे, राइट? अगर किसी और सिंगर के गाने सुने हैं तो आपके डेली मिक्स के अंदर वो सारे सिमिलर सॉन्ग्स होंगे. बिकॉज इन द बैक एंड स्पॉटिफाई इज लुकिंग एट मिलियंस ऑफ यूजर्स, बहुत सारे यूजर्स हैं, मिलियंस ऑफ सॉन्ग्स, एंड स्पॉटिफाई इज फिल्टरिंग आउट द पैटर्न्स. ओके, हु लिसन्स टू व्हाट, विच सॉन्ग्स गो टुगेदर, कौन से सॉन्ग्स आप आपस में सिमिलर हैं, वो सारे सॉन्ग्स आपको दिखाने का काम स्पॉटिफाई का जो इंजन है बैकएंड में, रिकमेंडेशन इंजन बोल सकते हैं हम, वो काम करता है, राइट? एंड इट्स डूइंग दिस बाय ट्रीटिंग ऑल ऑफ दैट एज अ जायंट टेबल ऑफ नंबर्स, एंड वी कॉल दैट जायंट टेबल ऑफ नंबर्स एज मैट्रिक्स. ओके, बहुत बड़ी मैट्रिक्स है, उसी पे मैट्रिक्स के ऑपरेशंस परफॉर्म करके ये जो रिकमेंडेशन एल्गोरिदम्स होती है, इंजन्स होते हैं, ये पैटर्न्स फाइंड करते हैं, हिडन पैटर्न्स उसके अंदर फाइंड करते हैं, और फिर वो रिकमेंड करते हैं किसी भी कंटेंट को, राइट? दैट इज लीनियर एल्जेब्रा. तो लीनियर एल्जेब्रा वहाँ भी वर्क कर रहा है. ऑल राइट, सो इवन व्हेन यू आर using a Snapchat filter, just like this. When Snapchat puts a dog filter on your face, it's doing a lot of maths on that grid of numbers. Okay, on that grid of numbers means on that particular image of yours. Okay, when you apply a warm filter on Instagram, it is multiplying every pixel value by a certain amount to shift the colors. That operation on a grid of numbers has a name. Okay, and this is called matrix multiplication. So matrix multiplication is what? Linear algebra. Again, so linear algebra is working almost everywhere. All right, now let me ask you a hypothetical question. Suppose you have your own application which has 10 million users. Wow, that's amazing. 50,000 movies. That's amazing too. Now, how would you store and analyze which user likes what? आप कैसे स्टोर करोगे कि कौन से कैसे मूवीज़ को स्टोर करोगे और कैसे ये पता लगाओगे, कैसे ये डेटा स्टोर करोगे कि कौन से यूज़र को क्या देखना पसंद है, क्या सुनना पसंद है? आप एनालाइज कैसे करोगे उसे, राइट? दिस इज़ वेयर द लीनियर अलजेब्रा इज़ बेसिकली वर्किंग. ओके, यू नीड 10 मिलियन इंटू 50,000, 10 मिलियन इंटू 50,000 की मैट्रिक्स, इतनी बड़ी मैट्रिक्स आपको चाहिए होगी, राइट? एंड देन यू नीड टू कंप्रेस इट. आप उसे कंप्रेस करोगे, आप उसमें पैटर्न्स फाइंड करोगे. यू हैव टू फाइंड द पैटर्न्स इन इट एंड एक्सट्रैक्ट द मीनिंग. Okay, and whenever there is a matrix and we compress that matrix, there is a chance of losing the data. So how do you compress a matrix without losing what matters? That is eigenvalues. Okay, वहाँ eigenvalues का concept काम आता है, and that's exactly what GATE is testing you on. Okay, that is all you have to learn for the engineering mathematics, right? We will be solving the questions in that came in the GATE previous year question papers. We'll be solving those questions as well. All right, but we will also be looking at the real world examples in between so that you can understand the mathematics even better. Okay, so that is one of the things. What I would suggest you is learn the mathematics by taking the real world examples in mind. All right, any subject for that matter, okay, for GATE CSE, any subject cannot be studied in silos. हर कोई सब्जेक्ट किसी दूसरे सब्जेक्ट के साथ कनेक्टेड होता है, एंड यू नीड टू कनेक्ट दोज डॉट्स. वंस यू डू दैट, the entire study will become very interesting. You will not get bored in any way. Okay, everything will excite you. So welcome, and this is going to be the first series that we are going to launch, engineering mathematics. All right, now these are the topics that we will be studying in the linear algebra. What are these? Matrices, determinants, inverse matrix, rank, system of linear equations, eigenvalues and eigenvectors, LU decomposition, Cayley-Hamilton theorem, and diagonalizability. All these are the concepts that we have to learn and understand and study in linear algebra. Okay, and we'll be taking real world examples of all these. Okay, so you will not get bored in any way. So that is about the linear algebra. तो ये सब linear algebra हम लोग इस 2D space पे भी देखेंगे, 2D plane पे, right? So this is a 2D transformation of how the matrix actually transforms. If we change the parameters, if we change the values, and we see how the matrix is actually transforming. So this is going to be, really helpful. When we visualize the things, it becomes very easy, it will be very helpful. Even in the 3D projection, we can see that how the matrices transforms. All right, how these how these vectors are working, how these vectors are changing the transformation of a matrix. All right, so this is a 3D space, right? And we'll see the 3D 3 by 3 matrix. We will see here how they are actually transformed, right? So that is one of the thing. Then next is calculus. So why calculus? Before even looking at what are the topics we will study in the calculus pillar, the second pillar, we should know why do we need to study calculus. So let us take these examples. Zomato and Swiggy, okay, they show you an estimated delivery time. As you may see, 26 minutes to work. All right, arriving in 45 minutes. Okay, arriving in 54 minutes. So that number keeps updating as the delivery partner moves. Okay, so this is the real time number. This particular time changes in real time, right, in the application. And that number keeps updating as the delivery partner moves. It is constantly recalculating based on the speed of the driver, based on traffic, based on distance remaining. So that is a rate of change problem. And whenever we say if there's a rate of change problem, we use calculus over there. Okay. And that's what the Swiggy, Zomato, and these applications are doing, right? Google Maps is also doing something similar. Like, let's suppose you are driving, all right? The traffic is changing, your speed is changing, the distance is changing. It is recalculating your route in real time. It continuously measures how conditions are changing and adjusting it, the application according to it. And that is the core idea of calculus, understanding and working with the things that are constantly changing. All right. When you open WhatsApp and when you send a video to somebody, तो WhatsApp क्या करता है? WhatsApp compresses a video before sending it. It is not sending the full video. It first figures out which parts of the video changed from one frame to the next. And it only sends the difference between those. All right. So it is basically tracking the change between frames, different frames. And that's calculus thinking. Let's take an example of ChatGPT. ChatGPT learns from mistakes. Every time the model gives a wrong answer during training, it makes a tiny adjustment. It figures out which direction to change its settings to get a slightly better answer next time. It does this millions of times. And the way it figures out which direction to change, that's calculus. The model is asking, if I change this slightly, does my answer gets better or worse? That is the core question calculus actually answers, right? So this is what the calculus is. Whenever we will be talking about the rate of change, wherever we will be talking about the rate of change, we have to think about calculus. Okay, and we'll be taking so many more examples later on as well, right? Even in our visualizer, if you can see, we will also be looking at the calculus space, the rate of change and all that in our calculus visualizer. So that is again very interesting thing. All right, and what do we study in calculus? These are the topics that we study in calculus. All right, these topics are limits, continuity, differentiability, maxima and minima, mean value theorem, integration, and all that. So this is what we are going to study in calculus. Now comes the third pillar, which is probability and statistics. Before looking at the topics which we cover in probability and statistics, first let us try to understand why do we study probability and stats. Here are the examples. Look at these examples. Now, every single email in your Gmail inbox that went to spam, Gmail makes a decision. It said, based on everything I know, there's a very high probability this email is a spam. So, जो Gmail का spam filter है, वो probability and stats पे काम करता है. Okay, वो check करता है probability of any email that is a legitimate email or if it is a spam. And that decision is made using probability, one specific formula from your engineering mathematics syllabus. That is called Bayes theorem. Okay, and this literally runs inside the Gmail, running inside the Gmail right now. Okay, so probability is working there also. Instagram decides which reel to show you next. It is not random. It is estimating out of all the reels available, which one has the highest probability of this person watching it fully and not scrolling past. This is what the Instagram algorithm actually sees. It's making probability estimates about your behavior thousands of times a day. All right. Amazon and Flipkart, take these examples. When they show you customers also brought something, okay, when you order a product, they show you that this, if you are ordering this, you may also be interested in this product. Okay, so it is showing, see, consider these items also. It is showing this Apple Pencil and then the Realme Buds and all that, all the products. All right, so how these recommendations are coming, how the application is showing you these recommendations. This is the probability and statistics. Okay, and then you can see another screenshot, products related to items in your cart. Okay, so whatever the products are there in my cart, okay, if it's a dumbbell, if it's a yoga mat, or if it's something related to it, then the application itself shows you the related products. Okay, and there is very high probability that you are going to buy those items next, and that's where the probability is working. All right, so probability is working in there in these applications also, Amazon, Flipkart, and any other e-commerce application, whether you say blanket, whether you say Zepto, whether you say your Instamart, okay, all those applications are using these algorithms based on probability and statistics. Okay, they have to show you the products related to whatever is there in your cart, and they have to show you the products which other people are also buying. Let's say you have bought a laptop from Amazon. Okay, so whoever bought that laptop from Amazon also bought something, and based on so many people's data, okay, it also suggests you that particular thing. Okay, okay, like they have purchased the laptop, they also purchased a laptop bag with it, and that laptop bag will be coming as a recommended item for you in the application itself. So probability is working there. Even the self-driving cars, at every moment, the car is asking, what is the probability that the thing in front of me is a person? What is the probability that it's a car? What's the probability it will move left or right? So it's making hundreds of probability decisions every second. One wrong estimate and the car crashes. This is why probability is not just theory. So in self-driving cars also the probability is being used. Right? So these are some real world examples, and we'll be talking about more examples as we move further in the sessions. Okay, when we will study that particular topic. All right. So now what are the topics that we study in the probability and stats? So here are the topics. Probability, conditional probability and Bayes theorem that we just discussed. It's running inside the Gmail right now. Okay. It also has a subtopic, law of total probability. We'll look at that. We'll see what are the random variables. We'll see discrete random variables and continuous random variables. Okay, and these are the subtypes of them. Then we'll see mean, mode, median, and standard derivatives. Don't get into the terms right now. Okay, when we'll study all these, you will get to know what are these topics and how we'll study further. So yeah, that was it in this video, and hope to see you in the next one. So that's it. Thank you. See you. And we are going to cover the linear algebra in the very next video. We are going to start with that. So subscribe to the channel and stay tuned for more videos and for more such series. This is just the starting from engineering mathematics, because this is the most important subject that we must study first before studying operating systems, database management systems, computer networks, all right, theory of computation, and all such subjects. So yeah, that's it. See you in the next video.